Hello, good morning, good afternoon, and good evening for all attendees for this new webinar. Welcome on the TMS Web Academy for those who are here for the first time. This is our webinar platform, the TMS Web Academy. And just in case you didn't know, Web Academy was in development that was done with our own tools. It's a TMS Web Core web application that you are using at this very moment. But you're not here for TMS Web Core. You are here for TMS FNC Maps, of course. So welcome everyone, and let's dive into the content of this webinar. So first of all, FNC Maps is a relatively new product. So first of all, a little bit background about the reasons why we have started the development of TMS FNC Maps. One of the first reasons, main reasons, was to break all the dependency from the Internet Explorer ActiveX browser engine, which was the browser engine that was previously used in former mapping products. At the same time, we also wanted to remove what we call mapping service lock-in. If you had been using a specific component for Google Maps, for example, in the past, that meant that, of course, as long as you were using that component, you were forced to keep using Google Maps or whatever other mapping service. And we thought it would be a good idea to remove that lock-in so that if for some reason you wanted to switch to another mapping service, that this would take the minimum amount of effort. And in this case, this minimum amount of effort is just switching a property setting. And together with this mapping service lock-in, there is also the reason for cost optimization. Some mapping services have a cost associated with using the service, and cost may vary for different services that are being used. And so having this freedom of choosing the mapping service you want for the functionality you want might lead to a cost optimization for your application. Also, the features and the way that different mapping services return different maps, different routing results, etc., might also be a reason for choosing the best service for your purposes, and even mix services so that you can take advantage of the best results from different services. You might also, of course, have a preference towards some specific service and easily switch between them with just a property setting. And finally, another reason for bringing this under the umbrella of FNC is, of course, code portability. With our FNC architecture, you can use the same code for different frameworks, target different operating systems, and so you highly benefit from this portability. So formerly, we had 4 products, which is, first of all, the very first product that we released that offered mapping services was the VCL TMS Web Gmaps. That was Google Maps only. It was a VCL product only. And of course, it offered various features of Google Maps for your VCL Windows applications. And then shortly after, we also introduced a Web OS Maps product, which was based on OpenStreetMaps, free and open source based mapping service. And when the FireMonkey framework was introduced by Embarcadero in Delphi, we also created the cross-platform version of the Google Maps component and the OpenStreetMaps component as FireMonkey components for products that we had. And in VCL at least, and also in FireMonkey on the Windows platform, we have been using the Internet Explorer engine to render the maps in your applications. And Google decided or announced quite some time ago that Google would stop supporting Internet Explorer engine. And so that was, of course, a reason to consider to re-architect these mapping products. At the same time, our Web OS Maps product was based on open layers, and the open layers framework has introduced at a quite high rate new versions of the API all the time. We started the development for Web OS Maps when this Open Layers API was at version 2.0, and I believe meanwhile they are at version 6 or 7, something like that. Introducing breaking changes, and so making a big move to a newer version of Open Layers was also overdue, so we also did that. I see in the chat box a remark about audio. I assume, and it's a known issue for Safari users on a Mac, that due to restrictions in the Safari settings, that the sound might not directly be, that you might not directly hear sound. There are Safari specific settings, so I suggest to Google for Safari settings to enable audio for our Web Academy, and that should work out of the box then. All right, so given this situation, it's around half 2019 that we made the decision to proactively re-architect our FNC Maps product from the ground up. And after, I think, more than half a year of development, we could finally introduce in April 2020 our first version of the Tms FNC Maps. And the goal from the very beginning when developing Tms FNC Maps was clearly to offer you the ultimate flexibility in using mapping services for Object Pascal developers. And with ultimate flexibility, we mean that you can use this library regardless of the framework, that you can use it regardless of the IDE that you are using, regardless of the target, and also regardless of the mapping service. In detail, this means regardless of the framework that you can use FNC Maps in your Windows VCL applications, that you can also use FNC Maps in your cross-platform FireMonkey applications and target this way the Windows operating system, macOS, iOS, Android, and also Linux. That you can also use FNC Maps in Lazarus IDE, the free IDE for Object Pascal users, and this way target the operating systems that Lazarus supports. And finally, also use FNC Maps in our own framework for web client application development, TMS Web Core. So also there, FNC Maps can be used. Regardless of the target, that is the operating system or the browser where the Tms FNC Maps will be used on. And that means, of course, Windows, macOS, iOS, Android, Linux, and also different browsers. So any modern browser will work fine with FNC Maps. Regardless of the IDE, the Tms FNC Maps product can be used with the Delphi IDE, starting from Delphi XE7 up to the latest Delphi 11 2.1 at this time, and the same applies for C++ Builder. It also works in Lazarus 2.0 and later, and it also works in Visual Studio Code when used together with our TMS Web Core hosted in Visual Studio Code. And also, regardless of the mapping service, and this is the status of today, this is the list of mapping services that we support till today. In the future, we might even add additional mapping services, but today we offer Google Maps, Here Maps, Open Layers, TomTom Maps, the Microsoft Azure and Bing Maps, and also Mapbox, and finally the Apple MapKit mapping service. When talking about mapping functionality in your Delphi or C++ Builder applications, we are mainly referring to visualizing maps, interacting with these maps. That means zooming, panning, moving into this map, etc. But also visualizing several types of information on top of these maps with the use of markers, lines, all kinds of graphic shapes, polygons, polylines, circles, rectangles, also in layers on top of the map display additional information. One example here is, for example, time zone information, and also add controls on top of the map. Other than visual mapping, there is also functionality related to maps, which is, for example, geolocation and reverse geolocation, which is the process of converting an address to a map coordinate expressed in longitude and latitude, or retrieve information such as the elevation, so the height above sea level of some specific location. Also directions, so calculating road to travel from A to B is part of what mapping services offer and is also available through FNC Maps. And there are also a couple of standard file formats typically used together with mapping services, and two of the most important ones are, of course, the GPX file format and the GeoJSON file format. And TMS FNC Maps can import, export in this GPX file format, and it can also read GeoJSON files and display this information on top of the map. Also, an additional often used service in connection with mapping is Lookup and address completion. So if you're typing an address, for example, based on your location, it can automatically autocomplete what you are typing, the address that you are typing, and make it faster, easier for the user to enter an address, for example, to look it up on the map or to calculate the direction. And places, this is also a service based on monuments, for example, government places, but also commercial places that you might want to look up, for example, a gas station or a museum. This is the kind of information that you can look up. So you type the name of some place you are looking for, and this service will return the options around the location where you are. I mentioned different services here, and through FNC Maps, it's possible to mix these services. What I mean is that, for example, you use the Apple MapKit to visualize maps, but that you use a Google service to perform the address auto-completion. And so you can choose what you want when you use the components that are included in FNC Maps. Before diving into some demos that we prepared for today, I think it's also good to provide you some technical background in how the mapping service actually works in your applications. Everything starts with a browser, as the mapping is visualized through rendering in a browser. So the visual component is actually a hosted browser in your native application. So the browser is responsible for rendering the map from the mapping service that you choose. And of course, interaction is offered, and that interaction is offered in a bidirectional way, meaning that the native application will perform script injection and execute code that is triggered from the native application inside this hosted browser. And on the other way around is that, of course, within the map, several things might trigger events. And of course, you will want to handle these events at the native application level, so that side of the communication between native application and browser is also covered. That is for the visual part that comes with mapping services. There is also the non-visual part, which is most typically offered through REST API services. We are talking here about geolocation, reverse geolocation, directions, elevation, etc. And here we are offering non-visual components that you can simply use by calling methods, and these will return the responses delivered by the different mapping services. And here we give you an overview of the actual browser engine that is being used depending on the operating system where you will run your application on that uses FNC Maps. Very important here is that FNC Maps takes advantage of the browser that is installed by default on your operating system. So that means that there is no requirement to deploy an additional browser-related files or browser, etc. on your operating system, at least on a modern operating system. No, TMS FNC Maps takes advantage of the pre-installed default browser that comes with your operating system. And on Windows, this means the latest iteration of what Microsoft is offering, which is the Edge Chromium browser engine, which is actually shared with the engine that is behind the Google Chrome browser. On the Mac and on iOS, it is the Apple-based WebKit browser engine that is used. On Android, it is the Chrome engine. On web applications, of course, you are already running in the browser, so there is no additional browser hosted within the browser. No, we are directly running everything in the single browser instance. And here we support any modern browser like Chrome, Firefox, Safari, and also Edge Chromium. And finally, it can also be used on the Raspberry Pi, where the WebKit browser engine is being used. If you have installed FNC Maps in your IDE, this is an overview of the components that you will see added to your component palette. But we will dive into these details in a moment. So let's get started and let's move to our IDE and explore the capabilities of FNC Maps. So first of all, let's open the first project prepared. And in this first project, we are basically showing how, with a single property switch, you can choose the mapping service that you want. So here we have a VCL application. Here we have the FNC Maps visual control. And here we have a combo box. And what we basically do, let's inspect the code. We are filling the combo box with the different mapping services that we can show or enable. And in the combo box change event, we are selecting the service that we want to use with the service property. And some services require an API key. The Open Layers, for example, is a free service, has no requirement for some key, but Google Maps and all the other mapping services need a key. And here the key is preset to the API key property of this component. Notice that the keys, the values for these keys are in this include file. These are, of course, private keys. These are not supposed to be shared with other people. That's why we define them as constants in the code, and they are in this inc file hidden. So each of you, if you want to use FNC Maps, should obtain his own key for his own private use. Let's have a look at the other included components. If we go in our component palette to Tms FNC Maps, and here are these components. So what we can see is the FNC Maps control itself to visualize the maps. And here already a couple of non-visual components that we will cover in a moment to calculate directions from A to B, to perform geocoding, for places lookup, to get the location of your device, etc. You also notice that here there are a couple of components like TMS FNC Google Maps, TMS FNC Mapbox, TomTom, Open Layers, etc. While TMS FNC Maps can, through its service property, if we select the component on the designer, through the service property, we can select the different mapping services that are provided, that are built-in supported. And this TMS FNC Maps offers the functionality that all these different mapping services share in common. There are, for example, in Google Maps, in Apple MapKit, etc., also specific features that are only available in Google and here in Apple, etc. So every unique feature or functionality that is only for Google, only for Apple, is actually covered in the separate component that descends from the TMS FNC Maps component, and offers, in addition to all the standard functionality, the functionality that is specific to a service. So if you use FNC Maps, write your code against FNC Maps, you can select the service and it will work for all services. If you need to take advantage of a specific feature that is only available, for example, in Google Maps, you might want to use the Google Maps specific component and you integrate that into your application. In a later demo, I will show you a unique feature of Google Maps, and that's why in that demo we will be using Google Maps. So let's first of all run this application. So it creates this Windows VCL application. And what we see here, of course, is the Edge Chromium browser hosted in this VCL application. And now I can select the mapping service that I want from this simple combo box. And as you can see, switching the service will also switch the view on the map. And as you can see, the map looks quite different for different services. So each service has its own way of rendering the map on the screen. Here we are showing the same map, same location, but in this case using the Apple MapKit service. Now I am using, of course, keys which are all valid, so it's quite normal that everything works as expected. Now let's cheat and let's destroy one of these keys. So let's make it invalid. And then we move to the application again. And what I will do here is actually let me show you the code. From this additional button, I execute the method show debug console. And so when I click this button, it shows us the browser debug console. So here I can see additional information about what is happening in the browser. And that is particularly useful in case you encounter problems. So if I now switch to Google Maps, everything should be fine. No problems at all in the browser console. If I switch to Apple MapKit, we see no map being rendered, and as expected, the authorization token is invalid because, of course, I made it invalid. But that was just to show you how you can debug in case you find problems with the FNC maps. This show debug console is a very convenient function for inspecting what is going wrong. So this is basically showing maps, switching between different map services. So let's move a step further to the second project. And in the second project, we will actually show some information on the map. And we will do that from a TMS Web Core web application. The code here in this application can be fully reused, copy and paste it into a VCL application or into a FireMonkey application. But here I happened to prepare that demo in a Web Core application. So it's a Web Core form. In our form designer, the mapping component is on the form. And what will happen here is render some markers on specific locations on the map. How this is being accomplished is what I do is I set the service to open layers. So it's the free mapping service that I'm using. And once I have set the service, I handle the event on map initialized. This is the event that is triggered when the map is ready for being used. It's only when the map has been successfully initialized that you can start working with the methods on this map. And so what I'm doing here is adding markers at specific location. So I added here the location, the longitude and latitude for two capital cities, for Brussels in the first place and for Paris in the second place. So I actually did a lookup of these coordinates. We will do a lookup of another city in a moment. And so at this specific location, a marker is being added. This is the location. This is the title for this marker. And here, if we inspect the list of parameters of this method, we can see that the third parameter is an icon URL. And the interesting thing here is that this is actually a custom image that I'm using here in this demo. And I encoded this custom image as a data URL and base64 encoded data URL. These are actually the two images that I encoded in base64. So let's inspect what actually happens. So a useful utility for encoding. Let me bring up that website. I bring it to the other screen here. So that's an interesting website that you can use to base64 encode images. And these base64 encoded images are actually a string and can be used as data URL based images for your maps. If I just drop the image that fits with Brussels on this website, you can see here the data URL for that image. So it's quite long. And I actually encoded that into string consts. And here you can see the consts in that file and that include file. You can see the base64 encoded version for the marker for Brussels, and the same applies to Paris. So this is actually the marker that I used for Paris. So the Eiffel Tower, and this is the Eiffel Tower in base64 encoded string. So that is what I will use as marker for these two cities. What I then do is I set the center of the map to the coordinate of Paris. So Paris will be in the middle of the map. And then I programmatically change the zoom level of the map. I do some more things. Here I'm using the coordinate of Brussels, coordinate 1, and the coordinate of Paris, coordinate 2. And what I actually do is draw a line between Brussels and Paris. And I draw a line by adding a polyline between these two coordinates. And I get a polyline object in return. So this is the Tms FNC Maps polyline. And for that polyline, I customize the color by setting the stroke color property. The next step that I will do here on this map is add a circle. And I will draw the circle actually between Brussels and Paris. So to do that, I determine the middle between Brussels and Paris. So I simply sum up the longitude divided by 2 and sum up the latitude divided by 2. And that will be the middle point between Brussels and Paris. And then I take the approximate distance between Brussels and Paris divided by 2, so that I get a circle that is between Brussels and Paris. And I set the opacity to 0 because when I do add circle, it is by default an opaque circle. And I set just the stroke color to red. So let's run this web core application. So it generates a web client application right now. And let's inspect the result in the browser in a moment. It is being compiled right now. And okay, we are almost there. It shows up here on the right screen. That's good. So this is our web core application. It tells at this moment that it cannot display Google Maps, and that is because there is no API key set. So it's normal. But in this demo, I set the service to open layers. So as soon as I did set the service to open layers, the onMaps initialized event is triggered, and this starts doing the work by adding the markers to Paris. As you can see, it is in the center of Paris that it shows this Eiffel Tower. In the center of Brussels, it is showing a famous statue in Brussels, and you can see the circle that is being drawn and the polyline between Brussels and Paris. As I mentioned, it is very easy to add another map, And for example, I can request the GPS coordinates from Berlin, another city. And this website here, for example, will return the longitude and latitude information for Berlin. So this is the information that I can directly use to add another marker, in this case, the marker for Berlin. So let's add this to our code. And so I will use here, I believe that that is the longitude and that's the latitude. I could be wrong. What I will also do, of course, we don't have an image yet for Berlin, so I don't specify it, and then we use the default marker image for the service that we are using. And I did make a mistake. This should be the longitude, and this is the latitude. That will be better to get the right position for Berlin. So let's run this application with this small modification. And let's see the third city being added on the map. So there we go. Here's the project and show the places. And so as you can see now, it shows Berlin on the map with the default open layers marker on Berlin, which is a small circle. And it also draws the circle in between these two cities. The radius of the circle was set fixed to 125 kilometers. So that's why you see the circle this way. So that was an introduction to using markers from FNC Maps and also circles and polylines. Let's move a step further with the third demo prepared for today. And in this third demo, which is an VCL application, we are going to have a look at element containers. Element containers are containers for HTML elements that you can add to the map at any place. So here in this open layers map, let's inspect the properties. We have the element container property. Here it is, which is actually a collection of containers. And you can see that there's one container added at this moment, and it is positioned in the top left position. You can change the position. You see that it changes on the map. We leave it in the top left location. And this is basically a container that holds any HTML that you want to add to a specific place in the map. Here in this case, the HTML for this container is this simple HTML button, and it has some specific ID. And this way you can add whatever HTML that you want to add on top of the map. But there is more. You can, of course, also interact with the HTML that you add to a specific place on the map. And the interaction comes from the actions, which is also a collection. And that's a collection of actions that you can use to make the connection between any JavaScript event that happens for the HTML element or multiple elements that happen to be in your element container, and a Delphi-based event handler for these elements. So here we have one action defined. This action is to handle the click on an element, and the element that will trigger the click is selected by the ID of the element in the container. And if I go to the events, the onExecute event is the event that will be triggered when I click that specific element in the container. And I do here nothing more than calling show message. So as you can see, you can add as much and as complex HTML that you want on top of the map in different positions on the map. And you can also add whatever event handlers you want to use. For example, this could also be a mouse in, mouse out. You can add a track bar here, for example, to change the zoom level. You can add an HTML input control. All these capabilities are open. Any HTML you want to add is possible. And take into account that you can also add CSS to style the HTML that you add to the container. So when I run this application, you will see that, of course, also at runtime, the element container appears at the location where I defined it. And if I click that button, it is at native application level that this message is being shown. So with element containers, you can actually add whatever functionality you want on top of the map and interact with it. Let's go to the next level of capabilities of the map, and that is to work with different standard file formats. And one of the file formats that is supported by FNC Maps is the GPX file format. It's a file standard for the description of polylines, typically associated with routes, or calculated routes from A to B, and such GPX files can be directly loaded into the map with the load GPX from file call. And here we will simply allow to pick a file and open it. At the same time, I also added here the code to loop through a set of GPX files. Actually, if we have a look at the folder, I have here like 12 different GPX files. You can see also the size. Note the size of these files. You will see in a moment what these files represent. And I simply loop through these GPX files, and in that loop load each of the GPX files. You can see that here this method is using the standard parameter file name. And here I have some additional parameters where I set the width, for example, of the stroke with which the polyline is drawn. And I also set a specific color for each of the polylines that represent the GPX files that I open. So let's run this application. These are actually GPX files that were recorded with a mobile device. So when doing bicycling, this recorded the entire bicycle track and exported it as a GPX file. And in this specific GPX file that we are going to load now into the map. So this is the result. So this is actually a bicycle tour recorded as GPX file that is shown here on the map. And of course, if you zoom in, you will see the recording in more detail. Like here, for example, you can see that we made a little mistake during this bicycle tour. And when I click on show all roads, it will now load these 12 pre-recorded GPX files and show them all together on the map and show these with polylines with different colors. So here is the result being rendered. It's quite a bit, because as you have seen, each GPX file is approximately 1 megabyte, so that already represents quite some data. And these are, as such, all different bicycle tours that were recorded. So it's actual information that is live, that was really recorded and happening. And you can also easily see that each of the bicycle tours started from home. And this is the actual recording from the home location where bicycle tours started. And so this way you can visualize this information on a map, in this case, in this application, on Google Maps, but the same would apply if you load these GPX files on top of open layers, Here Maps, TomTom Maps, or any of the other mapping services. So let's take this one more step forward, and let's have a look at geolocation. So geolocation is actually the process of converting an address to a longitude and latitude to a coordinate on the map. So what we have here is, for this geolocation functionality, the component, the non-visual component, Tms Fnc Geocoding. And we have an input box, which is the entry of our address. And when I click the button, I will want to show that specific location on the map. So I perform a get geocoding call to the non-visual FNC geocoding component with the address that I have entered. And the result of this geocoding is returned asynchronously. I'm calling a REST API service here. We do not want to freeze our UI during this call, this HTTP REST API call underlying, which is happening. And so it's an asynchronous call. I can handle this asynchronous function in two ways. Either I can use an anonymous method, which you can provide through the second parameter that you can see here, or we can also use an event for the geocoding component, which is what I used here. The event is triggered when the result has been received by the component. So on get geocoding, and from this event, what I'm doing is this event will actually return the longitude and latitude for the address that I entered. And so what I do is I get the values for longitude and latitude, and I add a marker on the map on this specific coordinate. And I also center the map on this coordinate, and I perform some zooming. So let's see what the effect is of doing that. When I enter the address in the map, and so here I will use an address that I know that is nearby, which is of course in Belgium, and it's actually the street called Drunkard number 10 in Rechem, Belgium. So the geolocation did its job. It located this specific street on the map, actually also the specific house number on the map. And the interesting thing here is that this specific location on the street is very nearby the border between Belgium and France. As you can see, here is the border between Belgium and France. And so here, this address is very close to it. I can, of course, enter any other address. If I would just add Amsterdam in the Netherlands and do the same, then it has actually positioned the map in the center of Amsterdam. Let's zoom out a little bit so you can see. So this is what Google actually considers the very center of Amsterdam, and it positioned the marker as such at that place. So this is what you can do with geocoding. There is also the process of reverse geocoding, which is the conversion between a coordinate, longitude and latitude, to an address. So if you click on a map, for example, on some specific coordinate, and you want to know what the address is at the position where you clicked, then you would use the reverse geocoding method, and it would return the address where you clicked the coordinate on the map. Let's move yet another step forward, and that is having a look at directions, the calculation of roads from A to B. And in this demo, we have introduced another component, a non-visual component, which is the Tms FNC Directions Component. And this component is responsible for calculating the road from two addresses that I specify. Also here, this is using a REST API call, so it's asynchronous. And also here we have an event that gets triggered when the calculation has been performed, when the route is known, and there the result is available. So let's first switch to how we do this exactly. We have the geocoding process that is used to enter the address of the start location, and also the geocoding for the to address. And the event that is triggered for the geocoding results, here you can see that I add a marker for the from location and also a marker for the to location. I took advantage of a parameter in the get geocoding call. Let's move to here, the third parameter. I have some identifier that I can just use freely as I want. And this identifier is returned from this event when the geocoding was successful. So here, by using 1 for the start address and 2 for the end address, I know which marker to add on the map. And I also center here on the address found. And then from the button to calculate the roads, this is the FNC Directions component, the non-visual components, for which I call the get directions call, and I specify the start coordinate and the end coordinate in this get directions call, and this will asynchronously trigger the event on get directions. And what happens here is that this event actually returns the results. That can be multiple routes from A to B, and in this route will be returned as a polyline, as an array of coordinates along the road from A to B. And so what I do here is I capture this array of coordinates and I add it as a polyline on the map. And finally, I also zoom the map to include that entire polyline, and this way it will ensure that our map sees the road from A to B fully visible on the map. So let's have a look at this functionality in action. And here I will actually come back to the Brussels and Paris. So I can add Brussels and Paris as the start location. So it adds the from marker on Brussels, it adds the to marker on Paris. So let's perform the calculation of the route from Brussels to Paris now. I perform calculate route, and as you can see, it has drawn that polyline of the road that Google, in this case, calculated. And as you can see, it has chosen mainly a highway to travel from Brussels to Paris. So you can see that this polyline is actually here in this specific case along the A1 highway in France. In this example, I used the geocoding service from Google, also the directions service from Google. And in the next prepared example, let's actually compare different direction services and also different mapping services. We are here for the first time in this webinar in the FireMonkey framework. So for this example, I created a FireMonkey application, but that same code could have been used in a VCL application or a web application or a Lazarus application. It doesn't matter. And so what we do here is quite similar. We have the geocoding component, we have the directions component. I added one more non-visual component in this demo, which is the elevation component. And the elevation component enables us to retrieve the elevation, so the height above sea level of some specific coordinate. It's also a REST API call that is used underlying. And so what I will be doing here is when I want to retrieve the road, I first call the elevation component get elevation call. It's also an asynchronous method that returns the response in an event. We'll see that in the list box, the result of that elevation. Here I perform the measurement, the distance between the starting location and the end location, which is the distance in bird's flight, I think it's the correct naming. So the direct distance between 2 points, and I add the result from this calculation in the list box as well. Measure distance is a helper function that is available in the FNC Maps product. And then finally, I perform get directions on the non-visual directions component. And in a similar way as the previous application, it will show the retrieved directions from that event on get directions. Only difference here is that I will perform get directions 3 times for 3 different direction services. And for each of the services, I will call it with a different ID. And through that different ID, I'm able to show the roads in different colors. It will become clear when I run this application what is happening. So this is a FireMonkey Windows application. It's also using the Edge Chromium browser. Because we are on Windows, it uses the native browser on Windows. And what I do is get the from location. It puts the marker on the map, the to location. And so these are 2 addresses that are quite nearby. And actually, these are 2 real addresses. It is on one side the address of our office, and this is the address of where my parents live. So if I want to go by bicycle, that's something I overlooked here, because in the get directions call from the location to the location, I can also specify what means of traveling that I want to use. So when I give this extra parameter, optional parameter, I can specify, please, direction service, also give me possible bicycle roads. And so when I calculate the road now with Google Direction Service, you can see that this is the calculated road. Remember that I also used the elevation component to determine the elevation height above sea level from the starting location and the end location. So here you can see that I will be starting in the office at 18 meters above sea level, and that I will have to at least that I will need to go 7 meters higher during my bicycle trip to arrive at my parents' address. And the distance here, the direct distance in bird's flight, is 5.3 kilometers. The Google road that is calculated is 9.13 kilometers. If now I use exactly the same code, but I use here, so here I set the service to the Here Maps service, and then the last one will be the MapKit service. Let's have a look at the result for same start and end location, but with Here Map service. You can see that the bicycle route is slightly different. It's actually also a little bit shorter. So when I'm going with the bicycle, I'm better off with Here Maps service. And I can also use a free service, the Open Road service. And you can see that with Open Road, my distance will be 8.4 kilometers. And it will use this green road here to travel from A to B, which in this case happens to be a way less interesting road, as it's using roads that are busy roads, also used for cars. So it will be slightly more dangerous when I would use the Open Road service to get to my parents. Here, these roads are visualized on Google Maps, and by switching one property, I visualize exactly the same road from A to B using the Apple Map Kit, or I can also switch to the free open layers based map and see the exact same roads calculated in open layers. And you can see all these maps offering slightly different visual information on the map. So that is what was concerning route calculations with the non-visual component for it. And I believe that with that, almost at the end. Let's go to project number 8, which is a project that shows us now the Google Maps specific component. So here we are not using TMS FNC Maps, we are using TMS FNC Google Maps, because in this demo we want to demonstrate a function that is only available in Google Maps. If we go in this component under options, here we see Google Maps options, and so this includes specific functionality only available in Google Maps. And what I want to show here is the capability to provide map tilting and changing the map heading with, at this moment still, a beta version of Google Maps. And I need to set the map ID here. This is a map ID provided in my developer console for Google Maps, because that is configured to use vector-based maps, and it is vector-based maps that we need to show this tilting and heading capability. To show you this in detail, I can open my Google Developer Console, which is here. So this is the Google Console. I go to Library. This is also what you should see when you open your Developer Console for Google. And I go to the Maps JavaScript API, which is the API that is used for all the Google Maps mapping services. And I go to Manage. You can also see in the previous form that this mapping that this API service is enabled. That's also critical, that you enable this service for use. If it's not enabled, it will obviously not work. If I now go, you can also see that all these different APIs that we have enabled these, like for example, the geocoding, you can separately enable or disable this in Google Developer Console. Elevation API, the JavaScript API is the one which is used to render the maps in the browser. And under map management, you will find here a setup of this my vector maps, and you can see here that the style or the type of these maps is JavaScript vector maps, and this is the map ID. This is the ID that Google has assigned to this map that I defined in the developer console. So this ID is what I configured in this map ID property. And when this is properly set up, this will enable us to change the heading and the tilting. And if we have a look at what is behind the trackbar event handler, here you can see that I changed the Google Maps options.tilt property with the position along the trackbar. And I also visualize the value that I set in the caption of the form. And the same applies to the trackbar that changes our heading. Here it sets the heading for the trackbar position. And so when we run this application, we will see this working. Here we are back in a VCL Windows application with the maps. Google Maps is what we see, and so if we change the tilting, you can see that the angle of tilting, and this is what Google offers, you can change it between 0 and 40 degrees, so you can see that it slightly changes the angle of showing the map. And here is the, with heading, you change the rotation of the map. Rotation, which can be a very convenient function when you want to use, for example, maps on your smartphone, and also always ensure that the maps point to the direction that you're walking. So these features, tilting and heading, are not available through all different mapping services. And that's why we added these to a descending component, this FNC Google Maps component that exposes this specific Google functionality. And last but not least, I wanted to show you our FNC Maps components in the Visual Studio Code IDE, and that can be used to generate web core web client applications, all from the Visual Studio Code IDE. So here we have Visual Studio Code, and let's first have a look at how FNC Maps is installed here. So I go to View, Commands Palette. From my Commands Palette, I can choose to have a look at the installed TMS packages here, and which is similar to packages that are installed in the Delphi IDE. It's the same concept. So here you can see that for having FNC Maps, obviously I also have Web Core Framework installed. I have FNC Core installed. FNC Core, which is which sits at the core of FNC Maps. So FNC Maps also builds on top of FNC Core, and then we have the FNC Maps package itself installed in the Visual Studio Code IDE. So now I will open a project that was built using Visual Studio Code. And here you can see the DPR file, the deploy file, the POS files for this project. And let's open the form designer. Let's Here in Visual Studio Code, you need to press Control F12 to switch between Form Designer and Code. That differs from Delphi, where it's just F12, but F12 was already used for other functionality standard in Visual Studio Code. That's why we had to use Control F12 to switch. And here you can see the Form Designer in Visual Studio Code, where you see the FNC Maps control added. You can also see here under FNC Maps on the component palette, all FNC Maps components available in the Visual Studio Code IDE. And just like with Delphi, you have the object inspector where you can change all mapping properties. And what is being shown here in this demo will not go in details that maybe can be covered in a later webinar, but this is showing how you can dynamically set or calculate roads in Google in the mapping component. So let's run the application. It builds our web client application now and we'll run it in a browser. It should be here any moment opening in the default browser, which is Google Chrome on this machine. Still compiling and generating the application. Let's give it some more time. Here you see, if I can make the compiling process visible. Still compiling while I'm using here the recording for the session. I have more load on my machine than normal, which affects and slows down this operation. So let's give it some more time to complete. But for some reason, the recording, the simultaneous recording of the session takes a considerable amount of resources. But here we are. It opens the browser for our Visual Studio Code project. This was generated with a trial version of WebCore. I did not bother today to install the license. And what I can do here, I can actually also pick a GPX file. So that same functionality is available in the web application in the browser. The same road is being displayed, and the purpose of this demo was to start the step-by-step routing. So if I click here and click there, it calculates the road as I click from point to point. And what is nice, if I want to avoid this place in my travel, I can simply take the marker and move it, and it will calculate a different route. And here from this application, I can even save the calculated route, as you can see, as a GPX file and download it from the browser. So all this functionality is available in pretty much the same way as it is in a native application. Of course, saving in a browser application means downloading a file. And so this was what I wanted to conclude with in this presentation for FNC Maps. And so let's move to the proper slide, which is this one. And okay, I want to show this full screen like this. Okay. And so this was the content for today's presentation, getting started with FNC Maps. And I would say that I scratched the surface of the capabilities that FNC Maps offers. There is way more than I showed today. It was an introduction. For example, things that were not covered today were toll cost calculations. So if you have toll along routes that you calculate, that you can also calculate how much it will cost to travel from A to B. The route calculator editor, tile layers was not covered. Custom tile servers that you can, for example, use in connection with open layers. Marker clustering, putting different markers together within one big marker, was not covered today. Google Street View that you can enable, Google Maps tiles, and many, many more small features were not covered. And these can possibly be covered in an advanced FNC Maps webinar. So let's use our poll, integrated poll into the Web Academy, which you should see right now on your screen. So if you think that this is valuable, that you want another webinar where these advanced topics would be covered, you can select yes or no, and that will give us direct feedback, direct input, whether we might prepare for another webinar. So I give you 20 more seconds to select yes or no, and then I should be able to see your result and see what the majority of you is thinking. It's counting down, and then I will have the results of this poll here. And what I see is that 95% votes for yes. I think that I should be able to share these results with you. 95%. So that looks like it will be desirable to host another webinar shortly with more advanced topics on FNC Maps. And that brought us to the end of this webinar. And so I'm having a look if there are any remaining questions that we can cover for you today. I see that my colleagues, Peter, already answered a lot of questions in the question box. And I see that the last question here is, if you go to the structure pane and right click the map, click about, what version does it say? So, okay, we can have a look what the latest version, well, the latest version, of course, is always visible on our website. So the latest version of FNC Maps, let's have a look on our website under FNC Maps. Here it is. And you see that the latest version is 3030. And in the IDE itself, here you see this component about. And I see, okay, but this is the Google Maps component separately. So these are versions for the separate components that are included in FNC Maps. So we track the version number of each different component in the entire FNC Maps product separately, so that you can actually see between versions what components underlying have changed or not changed. But the relevant thing is, I think, to check the version number on our website, and that's the version number of the entire product. So latest version right now is version 3030, and if you verify it with this component, and for you also have for this component the 2022 version 2030, then you must be using the latest version of FNC Maps. Okay, let's have a look if there are any further questions. Okay, the topic of migration, the migration from existing former products, WebG maps or Web OS maps. The interface is not one-to-one compatible, that's for sure. FNC Maps is re-architected from the ground up, and of course its architecture is radically different as it supports so many services. It meanwhile has way more features. It's also heavily based on asynchronous functionality to avoid any possible screen freezing. Of course, it's not, you cannot use the code that you used formerly with WebG maps or Web OS maps 100% identical with FNC Maps. So some redesigning will be due. The IDs are similar, but the interface is new. It's a more modern interface, a more flexible interface. We think it's well worth to re-architect existing applications to take advantage of, in my opinion, the way stronger phonation and a larger feature set and more flexible offerings in FNC Maps. Of course, if you have any technical questions during a migration process, you can always reach us via the support center or via email, where we will try to help you as good as possible. And I see no more questions for the moment. So if there are no more questions coming up right now, we will conclude the webinar here. And thank you, of course, for taking the time to learn about FNC Maps. It was an overwhelming positive response to get more, to see more advanced topics. So we'll work on that, and we will keep you informed as we have another webinar ready for you with advanced FNC Maps stuff. For the remainder of the day, I wish you a wonderful day. Enjoy the remainder of the day. And as always, be in touch when you have any concerns, questions, suggestions. Maybe you have exciting ideas for future iterations of FNC Maps. We love to hear it from you. Thanks for all the feedback. Have a good day, and till later. Bye-bye.